Emostel.
Hello, this is Emostel Academy and you are welcome to this video. This is going to be our first video in the series of MTH101 course. The course is for National Open University students, fine, and the fresher students of National Open University, but then it's something that anybody can benefit from in as much as the topic is relevant to you. All right, so the topic we are starting with now in MTH101 Elementary Mathematics 1 is set theory. We are starting with set theory, the part 1, because it's going to be divided into so many parts just for us to get it in bits and then understand it in bulk. Okay, all right, so in this part 1, we are going to be dealing with we're just going to be introducing sets by defining it and also by demonstrating to you the different ways in which sets can be represented. Okay, all right, so I trust you're going to enjoy this class. Let's dive in. All right, now what is a set? Well, a set is a well-defined collection of items. Okay, now most of the times these items that we collect, they usually have some things in common. Okay, and that is the reason why we group them into sets. We put them together into a set because there is something common about them. There might be different items. They are all different items individually, but collectively we call them a set because there is something common. For instance, example of set in real life is the set of students of 100 level students in National Open University. That is a set. 100 level first semester students, that is a set. Computer science students, that is a set. You know, everybody present there individually might be different, okay, but there's something common to them. The fact that, okay, all these people, we group them together as computer science students. So any collection of items that is defined, or that's given a definition, or that is grouped for some particular reason, or for the reason of what they have in common, that collection is what we regard to as sets. I believe you get that. Okay, now moving forward, there are two ways in which sets can be represented. The first way is what we call the set builders form, and then the second way is what we call the tabular form. All right, now the set builders form of representing sets involves the use of symbols and statements to represent a set, while the tabular form involves you actually listing the elements of the set. Okay, you list them visually. All right, so I'm going to explain each of the two. So let's delve in. Now, if you have sets in tabular form, let me just give you an example. For instance, excuse me. If you have something like this, all right, so now looking at this one, this is an example of the set builders form. This is how it looks like. It involves the use of statements and symbols. Everything that you are seeing here, they have meaning. All right, now this thing means something. It actually means in word or in statement, it means A, all right, like set A. You know, this coily symbol, we are still going to talk about that in the next video, like the symbols used in representing sets. But generally in mathematics, sets are represented, they are grouped, okay, using braces. Braces can also be called chord brackets, all right? So we use braces or chord brackets to, to group sets in mathematics, all right? General agreements, generally, conventionally, that's how it is. Okay, now, back. So we say A is a set, like it means, by statement, it means A is a set of, like A, this equality means is, all right? So this one is A is, then these brackets that you have here, and then the brackets that you have here, okay, the combination of the two brackets represents a set of, all right? It means A is a set of, okay? Then A is a set of X, all right? This symbol here means such that, it means such that, all right? So then this comma here means and. It means and, all right? So the whole of the statements here, okay, means, it means that X is between 0 and 10, all right? With 0 and 10 inclusive. That's the meaning of 0 is less than or equal to X, less than or equal to 10. It's actually trying to make us to understand that X is a number between 0 and 10, okay, with 0 inclusive and 10 inclusive. That's the meaning of the equality. If the equality is not there, it means anything greater than a 0 upward. But if the equality is there, it means 0 itself is included. And the same thing applies to 10. It means anything less than 10, if I do not put this thing. But if I put the equality under the inequality, it simply means that 10 itself is included. All right. So, but then the all of these things simply means A is a set of X such that X is even, comma means and, then X is between 0 and 10, with 0 and 10 inclusive. So that is the meaning of this statement. That is the meaning of this expression. We call it the set builders form. All right. We use it in a lot of ways in representing sets. There are many times it's used in sets. Even in advanced mathematics, we use them too. Even in computer science, we use them. All right. So just you need to just only understand the meaning of the language or whatever is it that is being expressed, and then you'll be able to understand clearly what the set itself represents or what it is all about. All right. So now let's go back into this business. So if we are to represent this same thing in the tabular form, this same thing here, so the tabular representation of this whole thing I just wrote here is going to be like in the form of A is equal to, all right, so we want to list all even numbers between 0 and 10. All right, so what are the even numbers that we have between 0 and 10? We have 2, we have 4, we have 6, we have 8, and then we have 10. So these are the even numbers that we have between 0 and 10. And this is the same thing as what we represent here. So in set builders form, this is what we have. But in tabular form, this is what we have. So I'm going to repeat whatever it is that I wrote here in a cleaner way so this thing doesn't distract you. So which means the set builders form of this same thing here is like A is a set of X such that X is even. Okay, there are more advanced way of writing stuff like this too, but as we advance, we'll be discussing them. Okay, so we have X, then so that X is even, then 0 is less than or equal to X less than or equal to 10, and then you close it up. So what I represent here, it means all this X is just like a pointer. It's not as if X itself is inside the set, but it's just a pointer. We need something to relate to. We say, okay, A is a set of some kind of numbers. So that is X in this picture now. A is a set of some kind of numbers such that the number is even and the number is less than or equal to X, but the number is greater than or equal to 0, okay, but less than or equal to 10. So in a nutshell, you can just use that X, you can call it a number, like an unknown number. Do you understand? So you can just like, okay, refer to it or see it in that picture of an unknown number. So A is a set of some numbers such that that number is even. And then, when you say 0 is less than X, mathematically, when you say 0 is less than X or equal to X, if you switch it the other way around, it's going to be like x is greater than or equal to 0. Do you agree with me? So if A is less than B, it simply means that B is greater than A. So when it comes to inequality, the moment you switch the inequality, the direction of that inequality will change. So if A was less than B, it means B is greater than A. Do you understand now? The moment you switch it, like you put your one of the term the other way around, then the direction of the inequality will also change. So if you say that 0 is less than x, okay, 0 is less than or equal to x, it means when we switch it, it means x is greater than or equal to 0. So that is why we say that x is a number greater than or equal to 0, but less than or equal to 10. So this one does not need switching because it's already in line, like x is less than or equal to 10. We don't need to switch it, but this one needs to be switched for us to be able to say it out, to interpret it properly. Do you understand what I'm trying to say? So, well, that's just how it goes. That's what this video is all about. Just to introduce you to sets, define sets, and tell you two major ways of representing sets, which we have achieved. Don't always forget this. Emostel Academy, learn, understand, apply that knowledge, and then excel. See you in the next video. Bye.